Hello everyone and welcome to Learn 360. Alright, so let's say I gave you a question like this and I asked you to find the the force in each member using the method of joint. Can you be able to do it? Okay, so let me teach you how to do this in this video. Alright, so this is pretty much simple and straightforward. The first thing you need to do is to consider the reaction forces over here and then over here. Now clearly you can see that at this point there is a pin or a hinge, and for a pin or a hinge joint we have got two reactions. Okay, so one reaction will be, let's say, CX in this direction, and then let's call another reaction, let's say CY, because it is a pin, two reactions. Now this is a roller support, so for a roller support only one reaction, let's call it D because just one, or let's say DX. All right, so now how can I solve and get the forces? Pretty much simple. Let's apply the equilibrium of a rigid body. So we are going to assume that the whole of this body is actually a rigid body. All right, so summation of forces along the X for a rigid body to be in equilibrium is 0. Let's do that. So we can say that CX, which is going in this direction, minus DX, which is going this way. Is there any other force we have not considered? No, so it should be 0. In other words, CX should be the same as DX. Let's say this is equation 1. Again, let's sum forces this time around along the Y. Every force which is going up should be positive. So if this is equation 1, this will be equation 2. Now, let's look at the forces in the Y direction. So 500 is going down, so minus 500. 1000 is coming down, so minus 1000. CY is going up, so plus CY. Is there any other force in the Y direction that we have not considered? No. So I think yeah, so that is it, should be 0. Now if I add everything, I can see that CY is what? So 1000 and then 500 is going to be 1500, right? We don't need a calculator to do this, yeah, because this is kindly straightforward. All right, so we know CY, we know CX, we don't know CS, sorry. Now from here we know that since I have two unknowns, then I cannot solve it. I need an extra equation. Now it will come from summation of moment. So these are very important. These three equations are very important. For a rigid body to be in equilibrium in a plane, summation of forces along the X must be 0. Summation of forces along the Y must be 0. Summation of moment, let's say clockwise, is positive about any of the point. Let's sum moment about C, should also be 0. And this is for what? Equilibrium. All right. So now let's start. So I'm going to sum moment about C. Now before you watch a video on truss, then the assumption is that you might have done moment. So I'll leave the link below for moment for you to also watch to understand the concept behind moment. Is that right? Okay. So now yeah. So let's do it this way. We are going to sum moment from C. The moment of dx about C, what is it? All right. All right. So it's going to be all right, let me do it this way so that I get it. So the moment of dx about C, Now, what is this distance here? So this is 8, okay? And then, so 8 feet. Now, is there a way which we can find this distance? Yes, tan, right? Because tan 30 will give me this distance. Let me call it, let's say, y over 8, right? So that I know that y is what? 8 tan 30. So I know that most people will say that the distance was not given. Please, this is how you can solve for it. So 8 tan 30, 8 tan 30, and that gives us this distance, 4.62. So this distance is 4.62 feet. Is that right? Now, having gotten this distance, we can then move forward and then we can sum the moment. Okay. All right. So, how do we go about it? So, since we are saying that clockwise is positive, the moment that dx creates about c is going to go in this direction, which is what? No, this direction is clockwise. Yes, so it is positive. So 4.62 multiplied by dx is positive. And then I'll come to any of the force. So maybe 1,000 pounds. Now the question is, what is this distance all the way here? All right, because if you don't know that distance, you cannot solve for the moment. So that distance all the way from here to here is what? Interestingly, again, we can clearly see that this distance, so if here is 30 and here is also what? 30. Interestingly, if this line is coming this way, then what do you expect? So we expect that this will be perpendicular to this, again will be perpendicular to this. Therefore, we can see that this distance here must be the same as this distance here. Uh, yeah, okay. Or we can also say that here must be what? 60, and then here must also be what? 60. Is that right? Don't forget that if I draw a straight line through here, 30, 90. So I just need 60 so that when I add everything, I'll get 180, right? Okay. So I just want to do something interesting so that you get why we are doing all of this. So vertically opposite angles are equal. So then we can even see that if here is 60, then this distance here, which is all the way coming from here, must also be what? So this is 60. This must also be 60. Vertically opposite angles must be the same, right? And this one will also be 60. Is that not it? Because this is also 60. Now look at this. You can see that clearly alternate angles are equal. So here is 30, right? And then alternate angles are equal. So again, here is 30. Is that not interesting? So I am just doing this so that you can appreciate what we are doing right here. Now, looking at it carefully, what else can you also see? Here must be 60, right? Again, looking at this extreme alternate angle, you can say that this must be the same as this, which is what? 60. Again, if you look at this again as alternate angles, so in fact you could have also said this is 60, so here will also be 60, right? Okay. And then again, what else can you say? If here is 30, then clearly here is 60, because angles here should add up to 190, right? This is interesting, right? So then what can we see? So if this is 30, then we can see that vertical opposite. So yeah, so this is 30. So what then can we see? So we know, in fact, this must be 30, because if this is 60, 30, so 30, right? Wow, this is interesting, right? Now, since we now know this, we can just find any distance we want at all. So we were just looking for the distance from this all the way to C. But because we now know that this is so this is like 60, 60, 60. So this is actually an equilateral triangle. This means that if we know even this side, it is going to be the same as this side, just like any other side, right? Okay. So then one thing that we can do is to solve for one side, and then we'll get the other side. All right. So I hope the concept is clear. Now, watch this. You can clearly see that this triangle is an equilateral triangle because 60, 60, 60. Therefore, if this side is 4.62, we can also say that this side is what? 4.62, right? Feet. So if this is 4.62 and I want to get this distance here, what do you think? Then it's going to be what? 4.62 cosine, right? So I'm trying to say that this distance is 4.62 cosine 30. Why? Because all of the sides here must be the same. Anyways, so let's go about C. So that's 30, right? And then is there any other thing? Yes. Now about this four sorry, 500 pounds. Watch this. The distance between the 500-pound force, according to the principle of transmissibility, the line of action of the 500-pound force is always in this direction. So I just need a distance from here to here, which is 8. So for that one, it's going to be straightforward, but then it's going to cause a moment in this sense, which is counterclockwise. So 500 into 8, which is minus. So minus 500 into 8, right? And we are saying that the moment should be 0. So once you do this, you should be able to solve for dx, which is the same as cx. So it's going to be 500 into 8 plus 1000 into 4.62 cos 30, all divided by um 4.62, right? So what is dx? So let's pick our calculators and calculate for dx. So dx is nothing but So 500 into 8, 500 multiplied by 8, and then so plus 1000 multiplied by 4.62 cosine 30. Is that right? Then I divide this by 4.62. Okay. So I'm going to get DS as 1731. So 1731 point what? 0.83 pound. So in fact, DX and CX are the same, and they are given by 1731.83. All right. Now, interestingly, we have not solved the question. In fact, this is where we actually begin solving the question. This is interesting. So now CX is the same as DX. All right. So each of them is what? 1731 point what? 83 pound. So 1731.83 pound. All right. So now we have CX and DX. Then we can go straight forward and solve for all the forces in the members. All right. So now this one is a method of joint question. Okay. So if I want to just solve it, I'm going to just go straight forward. Okay. We know the angle, so even if I clean, I can still do it. Okay. So this is what we are going to do. How many joints do you see? Joint A, joint B, joint C, and then joint D. So we are going to take each of the joints one by one, and then we will do the analysis. Okay. Now, if we take the joint one by one and do it, this is what we are going to get. So let's start from joint A. So we are going to assume that we only have A here. Okay. All right, let me clean. Now at joint A, this is what we are going to do. The force in member AB will pull away. So let's call this FAB. And the force in member AD, AD will also pull away. Let's call this FAD. So now how many members do you have? You have 3 members, right? So now what do we know? We know that from equilibrium of rigid bodies, equilibrium of a particle, the sum of all the forces acting at this joint is 0, right? For the joint to be in equilibrium. So let's start. So this is what I'm trying to say. Picture this joint and look at all the forces. So we are going to start with, let me bring it down so that you get what I'm trying to say. All right, so for the purpose of analysis, this is just joint A. And then over here, this is connecting A to the other joint, which is what? Joint B. So this is joint B, and this is D. So FAB, and then FAD. All right, and the angle here is 30. So if I bring the same thing here, here will be FAB, and then this one will be what? FAD. So now our interest is at the joint, okay? So summation of forces along the X, every force is positive, should be 0. Is that right? And then summation of forces along the Y, every force is positive, should be 0. Now let's look at it together. So it's going to be FAD, which is going in that way, plus what? FAB cosine 30 degrees. Is that right? For the 500-pound force, it is coming in the y direction. So that one, we don't need to worry about that. Yeah. All right. So then, I think that is it. Should be equal to 0. Okay. Let's call this equation 1. Now, summation of forces along the y. Minus 500, because the 500 is coming down. Then 0 for the FAD is 0. We don't need to bother about that. Plus FAB sine 30, right? Because the FAB, the sine, right, should be 0. From here, we can actually solve for FAB and say that FAB is 500 divided by sine 30, right? And what is 500 divided by sine 30? So 500 divided by sine 30 is nothing but 500 divided by sine 30. What is that? 1,000. So FAB is 1,000 pound, right? Okay. So now since we have FAB, we can go forward and say that FAD is nothing but minus FAB cos 30 from equation 1. But we know FAB, so it's going to be minus 1,000 cos 30. And what is 1,000 cos 30? So 1,000 cos 30 is nothing but 1,000 cosine 30. Okay. So 866.02, or let's say 0.03. So minus 866.03 pound. Now, interestingly, because this is negative, it tells us that whilst the force in FAB or AB, the force in member AB is 1,000 pound, which is a tensile force, FAD is rather a compressive force, right? And that is the reason why it is negative. Is that clear? So we are done with the first joint. All right. Now we are going to apply the same method to joint B. Okay. To joint B. So this time around, I'm going to also clean everything, and then we are going to assume that we are just at what? We are just at B. Okay. So let me clean everything, and then for the purpose of analysis, I'm just going to bring down okay, maybe I can just bring it. Okay, let me try and see. So I just want to bring only that part. Okay, let's see. All right, so for the purpose of analysis, I've brought this one down so that you can see it clearly. So now the same thing, we are going to assume that this joint is in equilibrium. Summation of forces in this direction positive should be 0. And then summation of forces along the y is also 0. You know, why are we doing this? We are saying that if the entire truss is in equilibrium, then all the joints are also in equilibrium. That is what it means. Okay, and for a joint to be in equilibrium, it's the same as saying a particle in equilibrium. And what are the conditions for a particle to be in equilibrium? Summation of forces in all directions is 0. Yeah? Okay, good. Now, what is this? This one is FB. So let me check. So FBC. Okay. So this one is FBC. What is this? This one is FBA. Okay, yeah. So this is FBA. And then this one. What is that? That one is FBD. Yeah. So this is FBD. But the interesting thing is that FAB, we know And then, interestingly, according to Sir Isaac Newton, FAB is the same as FBA. So we don't need to do FB if we know FAB. It's the same, and it's what, £1,000. So it's just going to come this way. So £1,000. Let me write it. We know. We don't need to worry our head. So this joint will help us to solve for FBC and FBD. Let's quickly do that. So we are going to sum forces along the X. So let's do that quickly. So FBC along the X, if I resolve it, is going to be what? Cos 30, right? And then FBD is also going to be what? Plus FBD cosine 30. Now, FBA I know as 1,000. So if I resolve along the X, so I can either use this, either 30 here or 60, right? If I use this 30, you know, it is coming this way, the S component, so it's going to be negative, right? So minus 1,000 cosine 30, right? And if I do that and equate to 0, is there any other force we have not looked at along the X? No. So this should be 0, right? So now we can write an equation in terms of BC and BD. So FBC cos 30 plus FBD cos 30 should be equal to 1,000 cos 30, right? In fact, we can just say that since they are all cos 30, then FBC plus FBD is equal to 1,000 because they are all FBD, they are all cos 30. So we can factorize cos 30 out. All right. Now let's sum forces in the Y, okay? Don't worry, we'll finish soon, okay? Don't worry. Now, so it's going to be for the 1,000, we can start anywhere. Okay, let's start from FBC. So FBC sine 30, and then we will do minus 1,000 because it is coming down. So this force is in the Y direction. And then FBD. So that one, this time around, watch this. This time around, FBD is coming down. The Y component will come down. So minus FBD sine 30. Is that right? And then yeah, we have done FBC, we have done 1,000, we have done FBD. Yes, we are left with this. So this one too, it will come down. The FBA part will come down. So it's going to be what? FBA, which is 1,000, and then sine 30, but it's coming down. So 1,000 sine 30. Okay, so I think we are done with this part. Let's look at it critically because I don't want us to make a mistake. Yeah, I think we are on the right path. Should be equal to 0. Now, please, I beg you, don't just say that, oh, sine 30, and just cancel out. No, take your time, please. All right. So now, this is what we have done. You know, FBC sine 30 minus FBD sine 30 is equal to 1,000 sine 30 plus 1,000. Now we just try to arrange it. Okay. So the question is, we need to divide 1,000 sine 30 plus 1,000. Then I divide this by sine 30. Is that right? Yeah. Oh, that is 3,000. Interesting. So this is going to be 3,000. All right. So if I solve these two equations simultaneously, what am I going to get? So please, this one you can use your calculator to do it straightforward. So you go to equation, which is 5, and then you go to 1. So FBD, the coefficient is 1. FBC, sorry. So 1 plus 1 is equal to 1000 for the first part. And then for the second part, 1, which is FBC, minus 1, which is FBD, should be equal to 3000. If you solve for this, FBC is 2000. So it means FBC is 2000 pound, and then FBC, and then FBD is 1000. So minus 1000 pound. Okay. Now because it is negative, it means that FBC is a tension or a tensile force, and then FBD, so FBD is a compressive force, 1000 pound compressive. All right, so now we know, right? Now we know FBC and FBD. We will go soon, so please don't worry. Now that we have been able to find FBC, FBD, and all of this, we need to find the force. So okay, let me brief you on what we have done so far. Now please watch this. We have been able to use joint B. So now this is the progress. Let me show you the progress. We know FAB, okay? We know FAB, we know FAD, isn't it? Now we know FAB, which is the same as FBA. Don't forget that so this is FAB. Don't forget that FAD is the same as FDA. And then don't forget that FBC is the same as this FCB, the same thing. Now, interestingly, don't also forget that FBD is the same as FDB, okay? So, FDB or BD. So now, interestingly, we are done because we have done everything. But now we only need to find FCD, right? So now the choice is yours. Since we have only FCD to find, you can either stand at C, because now you know FBC, so you can find FCD. You know this CX, right? Or you can come to D, but watch this. At D, I have 1, 2, 3, 4 forces to deal with. But at C, using the same, finding the same force, I have 1, 2, 3 forces to deal with. So why don't I use joint C? So let's use joint C to find FCD. And after finding FCD, we don't need to use joint D because we have found all the unknowns. I hope it makes sense. So let's use joint C to find FCD. And then hopefully you can grab a coffee. You can grab a cup of a coffee, right? Okay. So let's look at joint C. I want us to look at joint C. All right. So if I stand at joint C, this is what I would see. So if I stand at C, this is what I would see. Interesting. All right. So basically, here is joint F or force FBC, which is the same as FCB. All right. This is also the same as FCD, right? So BC, CD. All right. So BC, what is FBC? We have already solved for FBC. We know FBC is what? 2000. So 2000 £2,000. What is FCD? That one we don't know. So it is here as FCD. But we know that the angle here is what? So the angle, so earlier on we were able to show that this, this angle here was what? It was 60, right? Because if I remember, we said that this is 30, this is 60, right? This is also 60, and then this is 60. Any way you want to look at it, this side is 60. And please, this one, if you don't know geometry, you cannot solve it. So this is not basic mechanics, this is geometry. All right. So this is 60. I hope the concept is clear. And then, of course, here will be 30. Once you know this, you are done with the question. So then, so this is 60, right? So then this is 30. So we are almost done. So summation of forces along the x should be 0. So let's do it together. 1731.83. So this one. And then FCD is coming vertically down. So no force along the x. But then £2,000, the x component is going to be £2,000. And then what? The x component will come this way. And that's what? Cosine. So minus 2,000 cosine 30, right? And then, is there any other force along the S that we have not considered? Okay. Let me check it well. All right. Yeah. So we are here, right? And we want to find FCD. Okay. So what are we getting? We know that FCD is vertically downward. So okay. In fact, we could have just used the summation of forces, because FCD is going, this should be 0, right? This should be 0. Okay. So we are ending up with this because there is no force along the x for FCD. But if we look at the y direction, then we can see that so minus FCD because it's coming down. Then we resolve and get the y component of the 2,000, which will come down. That one to be minus 2,000 sine what? 30. You could have also said 2,000 cosine 60 is the same thing. Should be 0, right? And then FCD will be what? So FCD is going to be minus, so 2,000 sine 30 so 2,000, okay, let me clear. 2,000 sine 30 is 2,000, please. Sine 30, that's 1,000. So FCD is actually minus 1,000 pound. But then, because it is negative, FCD is going to be 1,000 pound, but then a compressive force. So let me correct this here. You see, 2,000 cosine 30 is what? So you see that it is almost 1732.05, and this is 1731.83. So it's actually saying that this is correct. All right, it's almost correct. So basically what this is telling us is that FCD is what we have got here. So in fact, we have been able to solve the question and we have found all the members. So this question has been solved. I hope the concept is clear. Thank you for watching, and if you have a question, please leave it in the comment section. See you in the next video. Bye.